So I'd like to introduce everybody to our team. We have me, I'm Victoria O'Leary. I'm the RASCAL project lead for RASCAL. And we also have joining us today, Pat Troutman. Hi, Pat. So Pat is our industry expert who's going to be joining us today to answer the questions that were submitted in advance for everyone. So we will go ahead and get started. If you are just joining us and your mic is not muted, go ahead and mute your mic. That way we can have a clear call for everybody. So we will go over the agenda right here. First, of course, is the welcome. Welcome, everyone. We're so glad that you all could make it to the session today. We also appreciate all of the questions that you submitted in advance. If you submitted a question and you don't see it here on the Q&A session, it could be that we require a little bit of additional input from our government friends, and they are not working right now. So you will get the answers to those questions as soon as they return from their furlough. We will cover first in between here is going to be a little bit of insights on this year's theme with Pat Troutman, and then we'll be covering select questions received in advance. I'll be reading the questions and Pat Troutman will be answering them. Then at the end of the call, we'll go ahead and take any additional questions that are follow-up questions to anything here, or any questions that you would want to add if we have additional time. And we'll do a short wrap up with some reminders and some information on how you can submit questions in the future. So for now, I want to turn it on over to Pat Troutman here. Pat is a retired NASA. He used to be RASCAL's primary sponsor before Dan joined the team. He also is recently retired and joining the RASCAL steering committee member as of last year. So welcome, Pat, and thank you so much.
Okay. All right. So sorry, just paraphrase, I've been doing RASCALs for over 20 years. This is the first year that I did not create the themes, but I did have lunch with the guys who created them, and they filled me in and hence helped me answer the questions before the shutdown began. All right. The themes are driven by exploration needs that are common across the Moon and Mars, although we'll pick a particular destination for some of the themes. First one being the Mars Communications and Navigation Network. That one is critical for enabling the safety of the crew and enabling good science in a host of different environmental conditions. Remind me, Tori, what's the second one?
You have lunar surface power and PMAD architectures.
Oh, it's right there in front of me. Okay. Lunar surface power and PMAD architectures. You might have heard that the acting NASA administrator, Sean Duffy, within weeks of being administrator or acting administrator, put out a call for a nuclear reactor, 100 kilowatt class fission surface power system. That was actually came up after this theme was created, but it fits in very well with it. In order to spend more time on the moon, in order to have more extensive reach and take advantage of the resources, we need more power. We need power spread out. So this theme is about answering that question. How do we get more power, which enables use of in-situ resources, which enables longer duration stays, which enables more science and more capability. So power is super important. We're all relying on it right now here on Earth. We need a grid on the moon too. Lunar sample return concept. We've had in RASCAL's concepts before requesting lunar sample containers. This is a little higher in nature. This is looking across the whole operations and systems, collecting the systems on the surface. So it's how do the astronauts find the samples? How do they tag them? How do they put them in the carriers? And how do those carriers preserve the integrity of the samples while they're on the surface being weighted to transport? It's not about transporting the samples from the moon to Earth, but you certainly have to take that consideration in your designs. And then the last one, lunar technology demonstrations, leveraging common infrastructure. This was actually a theme championed by the NASA Science and Technology Mission Directorate, the Space Technology Mission Directorate. They're looking for ways of using smaller payloads to address some of these long-term infrastructure requirements having to do with power and ISRU and manufacturing. So there's a list of particular objectives that they want you to create payloads for that will get you along the way to those objectives. again, this is all about increasing our footprint on the moon and Mars and operating there in a safe, efficient manner and getting good return on the taxpayer's investment. Okay.
Thank you so much, Pat. So we are grateful for Pat for kind of digesting those themes for us. We do appreciate it. Pat, I'll go ahead and leave my mic on and we'll be able to hear you through there. So we will begin going through the technical questions received in advance, beginning with the CP&T architectures for Mars surface operations. I'll be saying the questions and Pat Troutman will be answering them. So for your first question, Pat, what scope is expected for teams to provide in the proposal? Does the theme call for a launch vehicle trade study? Are we encouraged to select a launch vehicle or just present the alternatives?
All right, so as I said in my little prequel, the theme is not about the space transportation aspect of it. It's about how we operate safely on Mars and how communications and navigation do that. So you need to identify what systems you assume to get your communication infrastructure in place as a significant portion of the cost, but you're not designing them. So for example, I used a Falcon Heavy to deliver 10 tons to Mars or whatever. That's about all you need to do, and you need to make sure that your payload fits in the Falcon Heavy strap. So you have to demonstrate that those systems can actually get those launch systems, get them there, but you don't have to design the trajectories or design the launch systems. Just, well, is there a rocket and stage capable of getting you to Mars? Manifest showing what systems are launched on what launch vehicles is really important, and when they are launched, and that'll help you with the costing and your technical viability too.
All right, moving on to the next slide. In what time frame should we assume this operation will take place? For example, 2035, 2040, or later?
So this is a great question because we don't know. But the theme states the infrastructure will support both robotic and
Oh, there we go. Got it.
Yeah.
Hi, if you can hear me, go ahead and mute your mic. We did just hear you. Thank you.
So robotic and crewed operations. So the robots are already there, right? So really the sooner the better. But we want to hear your rationale for when you think the infrastructure would be ready to support those human missions. And again, as a function of cost, risk, and time. So if you think that humans are going to be on Mars in 2030, then you're going to have to put a lot of dollars and effort up front. If you want to take a more reasonable perspective of when humans might get there, you tell us how much it'll cost and it'll take to get by that particular time. So we're not putting a date on when humans go to Mars. You tell us when you think you can accommodate human operations.
All right, question 7. Does the project scope include the initial phases of human Mars exploration, or should the discussion focus on supporting sustained human presence? Should teams design their architecture to support early human Mars missions or for a later sustained presence?
So in this case, the earlier the better, because we don't know what sustained human presence on Mars is. That would require you to do that whole separate study of that isn't justified. So think about the first few Mars missions where humans are landing at various sites, maybe on one spot, and expanding their infrastructure over less than a decade. So early on, not good.
Next question. What is the appropriate level of technical detail recommended for hardware required to support Martian CP&T?
Okay, so in all the things, we don't want to say we're going to use quantum communications and it will be matured to TRL9 by the time we go to Mars, because we think it'll happen. You have to justify what technology you're using. So if it's a low TRL technology, that's great, but show some analysis and proof as to how that's going to mature to something that's operational in the time frame we're talking about here. So for technology in between, you can do a combination of high-level analysis, system design, and analog comparisons to validate the concept. But you just can't say we're going to use this technology. You got to show why that technology is viable in the time frame of the mission.
Number 9, which landing sites should we assume are appropriate for Mars? What level of latitude flexibility is recommended?
All right, so I want to bring this up now. There's a document that's in the references called the Architecture Definition Document. I worked on this the last 3 years before I retired, because what it does, it describes the Moon to Mars architecture, what we need to do, what we try to accommodate. So some issues about where we're going to land, of course, are still open, but there's a good discussion in there about what the selection criteria and the characteristics of the landing site should be. So that's your guidance right now. Go read the A to D, and there's a link on the resources page to get it in. That should be your Bible for this whole competition. That is the Moon to Mars architecture. And a lot of places, it's purposely vague because we don't want to find something now that we haven't figured out yet. We just don't want to say something to say something. So we're looking for your rationale for why you think sites A, B, and C would be good on Mars and how you adjusted your architecture to accommodate those sites.
And number 10, is there a maximum budget that this theme imposes for CP&T architecture? What is the acceptable yearly recurring cost for sustained human presence on Mars to enable CP&T?
So that if we were further along in what our Mars plans were and actually had a Mars budget, I would tell you that. But we're not. Mars is going to be tens of billions of dollars when it happens. And if you propose a CP&T system that costs tens of billions of dollars, your system's never going to happen. So you have to think about something that is launchable, is patchable, has reasonable technology readiness, and tell us what's going to be. So it can't be a huge percentage of what it would cost to send humans there, because there's a bunch of other things that have to be developed too. So keep it reasonable.
All right, number 11. How does NASA define the term normal operations in the RASCAL Theme 1 description? Should we assume environmental factors like dust storms and solar flares are considered normal as a part of the normal operations term?
So there are things in the ADD called use cases. And it's a great question because those are the things that are talking that you have to be able to operate in. So the answer is yes. It's actually sort of in the theme talking about dust storms. So read the use cases in the ADD and design to that.
All right. Moving on to number 12. What's the role of the private space industry in this operation? Could they also be operating on Mars alongside NASA or for NASA through a contracted commercial program like the NASA Commercial Crew Program?
So I would say if the past is any indication of the future, you're seeing more commercial involvement in everything. So that assumption is up to you. But both commercial and NASA role assumptions should be supported by good rationale. Just don't say SpaceX is going to pay for everything and land everything and starships. That's not acceptable. You got to think of what your concept is as a realistic scenario that makes a good movie or good book. It's got to be supported by something. Magic just can't happen.
Along those lines, what is the role of partner countries in Martian exploration?
The same deal. It's wide open. But again, if you say we're assuming that Yugoslavia is to provide all the habitats for free of charge, you won't get scored very well.
Number 17, this is a longer one. Are there specific Mars surface operational zones that the CP&T architecture must prioritize? Are we required to completely support the entirety of the surface, or should we target any particular areas?
So this is sort of related to the previous question, where we land. It's a very good question because we don't know yet. There's a bunch of, we have rovers operating places that could be future human sites right now. It is not clear, but use rationale, use the ADD and say, well, here's some examples given the ADD. And if we use these particular sites, this is what our infrastructure would look like to support those operations in the ADD. So let's go read it. And if you reference the ADD as an assumption, that's good. You don't have to justify it.
Are there any extraneous requirements for the communication link between Earth and Mars or Moon?
So again, this is a great question. This is the first theme I went through, so there's a lot of things about go look in the ADD. But there's a section in there called technology gaps. And they go into that next level of detail about, uptime, security, reliability, power needs, visibility. There are gaps. Those are the gaps we want to cover. So address those gaps, and you're addressing our design needs.
All right, next question. How should we structure our design to support the timing of real Mars missions from initial scouting or cargo missions to early crewed missions to full-scale surface operations?
So this is part of your design. So the answer is yes, you should do this. Tell us how you're going to do it.
The prompt mentions lunar surface testing. Should teams provide a realistic demonstration concept with specific systems and sites, or just identify which elements of the Martian surface system could be validated in the lunar environment?
So more leaning towards the end, what systems could be validated there. But if there's one particular instance of a technology and operation that would be both beneficial to the Moon and Mars, then maybe you want to propose it.
All right, next slide. Should the architecture support both robotic precursor missions and crewed missions, or only crewed operations?
Yeah, so that I answered that before. Early and better, robots is happening for humans, so you want to expand the robotic phase into the human.
What are the official mass, power, and volume constraints for the total CP&T system, including orbital and surface assets?
So again, that's up to you. Read the ADD. Consider again that everything that in your architecture is not going to go on a giant starship and spend billions of dollars. You got to size it right, and that's totally up to you. But tell us how it fits in the shroud. Tell us how it's deployed. Tell us what you're going to launch it.
Next question. What is the minimum required TRL for key components in the final design?
So that's sort of a tricky question because, you know, things at TRL now are low, but you know they're going to progress. But if you can show and justify how it gets to a TRL 9 for mission operations, that's what we want to see. How are you going to mature that? How are you going to invest in it? How are you going to test it and do analogs to get it to that point? Unless it's already done or very close, then you don't have to do it.
Next question. What is the required data rate, uplink and downlink, for human-tended habitats versus robotic or scientific assets?
So that discussion is all in the ADD. If it's not, Mars is a little more sparse than the moon section. So use the lunar information if there's nothing in Mars in this statement.
Is an optical communication link, laser-based, a viable option for high bandwidth data transfer?
Of course, that depends on the situation. You tell us and back up your assumption with analysis.
All right.
Not hand waving allowed.
No hand waving. Last question in this theme that we'll be covering today. What is the most significant risk NASA sees in current Mars CP&T concepts? And are there any historical lessons learned from past NASA missions regarding CP&T failures that we should address?
So the risk that's stated in the theme is loss of communications with the crew due to space, environmental, and system effects. Cost of deploying these systems has always been a major programmatic risk. Again, it has to be reasonable. There's a organization in NASA called SCAN, which does a fantastic job of designing very complex and capable communication systems relays. And they always cost too much. So we want to address all the risk sets, but keep it in the cost box. That's reasonable.
Thank you, Pat. And that is the last question for the CP&T theme. We'll be moving on to lunar surface power and PMAD architectures. Moving on to question number 1. Is the main focus of this theme scalability from Moon to Mars, or mainly scalability on the Moon? And should our design prioritize scalability for both early lunar missions and future Mars expansion, or focus solely on lunar applications?
So again, it's called the Moon to Mars program for a reason. The lunar applications are where your focus should be for this theme. There's a lunar surface power and PMAD architecture. But if you can identify how it's applicable to Mars, how do you benefit Mars, that's extra credit. It's good stuff.
Number 2, is there a budget limit?
Yeah, as I said before, there's no budget limit here, but you got to be reasonable. And this is part of the learning process. You as a team have to look at what NASA has spent on various aspects of crewed and robotic missions and come up with something that's reasonable. In the past, in Rascals, we've seen, well, we're going to launch 27 starships and 37 rovers, and it's just not reasonable. We shouldn't have to tell you that. You should look at history and tell us what's reasonable.
All right, next slide, number 3. Would there be an active Gateway lunar space station as seen in previous years for cargo loading and unloading, or to facilitate crew transfers?
So the current plan for the human leg of the mission is, yes, use the Gateway, except for the first lunar flight. It doesn't mean that you don't get extra credit for coming up with an architecture that doesn't require the Gateway. Justify your response. Make it make sense.
Next question. How detailed must submissions of the proposal be in regards to the evolution of the power infrastructure as time and missions progress?
So for the proposal, be wise to identify these concept characteristics that enable the infrastructure to evolve. The final presentation must demonstrate evolvability through design and analysis, but a timeline. We really love, the judges love to see these timelines. Oh, here we have 10 kilowatts. Here we have 100 kilowatts distributed to 3 nodes. Show the evolution of the system, and then get to a point where your design stops. Say, it can evolve this way if we add 3 nuclear power plants. It can evolve this way if we do this. So again, it's all about telling a story. It's about coming up with a cool idea, a cool design, and showing how that meets the needs but has potential for the future. And that features both the moon and Mars.
All right, next slide. How critical is autonomous fault detection in early lunar PMAD systems? Should we assume autonomy, or is human intervention acceptable?
So human intervention is always acceptable. It makes the best movies. However, the humans only be there 1 week a year initially, at best. These systems are not autonomous, not self-healing, or not maintainable by robotics, or fairly robust. They'll crash. So autonomy, in my opinion, is critical.
Does NASA expect a minimum life expectancy for the PMAD systems?
All right, this is one of those where I remember discussing requirements 6 years ago, and we had a requirement, I think it was 10 years of operation for surface systems except with maintenance. The ADD has been updated, so checking the ADD, but I think it's 10 years. I could be wrong.
All right, we'll have to get a little extra clarification on that. What is the expected program timeline and deliverable horizon? For example, 2 years or through 2030?
So I mentioned this announcement of a 100 kilowatt nuclear reactor. The timeline really isn't clear. If you look in the ADD, there's a segment called foundational exploration. At the end of that foundation exploration segment is when the fission surface power plant comes in. So again, read the ADD and don't necessarily put a date, but you could say by the end of this segment, we'll have this in place. And put that on your timeline. Without a date, it's perfectly acceptable. Now, if you have to do cost and risk, you have to assume some dates. So assume some, but do the best to base it on the ADD and the current progress that the program is making, which is a little bit behind schedule.
So how does NASA envision large-scale infrastructure being constructed or deployed on the lunar surface given current transport and equipment limits? And can permanent infrastructure be robotically deployed before crew arrival, or must all systems be human deployable?
Well, so in the original architecture, we had a phrasing, an army of robots will get there and prepare the surface for the humans to come. So that's not going to happen because we don't have enough money for an army of robots, but the robotic deployment is preferred. Now, if it can be done cheaper with humans and it's not critical for the humans, then why not use the humans? But the humans' time is so expensive. It's, you know, the recent number was $4 billion a launch. Well, that's $1 billion for each crew member to the surface of the moon. So he's there for a week. He's making $1 billion a week. You really want to spend that $1 billion a week setting up the space potty or something like that. So their time is very valuable. So if it's done cheaper robotically, do it robotically.
So are hybrid generation concepts like solar fission and storage encouraged, or should we focus on one primary source?
So that's up to you. What delivers the best combination of risk, performance, and schedule and cost is important. We call it dissimilar redundancy. So I could have a solar array and I can nuclear plant. If something goes wrong, the solar array and a set of batteries can pick up. So hybrid is the way we're currently going. I would not suggest you just fixate on one thing and have a common cause error ripple through the system and the astronauts get cold.
All right, next question. What are NASA's safety and waste management expectations for nuclear systems? And, let's go back. What redundancy and fault tolerance levels are required, and should recovery be autonomous or crew assisted?
So see the ADD on this one, the whole sets of discussion on it. But recovery from faults is part of your concept. We want to know how that's going to happen. If it breaks and it's done forever, the judges will have no mercy for you.
All right, now we're here. What are NASA's safety and waste management expectations for nuclear systems, and are there current concerns about their use on the moon?
Always concerns when you're talking about nuclear. Where do I put it? How far do I have to keep it? How do I maintain it? As I mentioned, there's a recent solicitation put out for a 100 kilowatt class nuclear reactor. I would look for that solicitation and see what it says, because that was again after these things are come up with, but that's extra information. So look for that. That should be your definitive source. And if it's not in there, then you have no better information than the industry does.
So for solar-based systems, what backup solutions are acceptable during eclipses or extended dark periods?
Yeah, all options are on the table. Identify risks and technology gaps. If someone wants to propose a lunar rock gravity system with things generating energy falling down Malapert Mountain, go ahead. They've identified the risks and the technology caps in doing that. So yes, we always want backup when it gets dark or someone blows a fuse.
So that is the last question we'll be covering in this theme. And now we'll be moving on to the lunar sample return concept theme. And our first question, the theme mentions addressing a variety of sample return use cases, from collection and storage to transport and preservation. Should our concept focus narrowly on a specific system like sample pods, or is it also acceptable to design a more comprehensive system that integrates collection, transport, and storage?
So it's the latter. The theme specifically says we want to understand the operations and the systems on the surface required to identify, gather, contain, and store the samples. So it's that later one. So no narrow focus. We actually had a theme a couple of years ago where we did a cryogenic sampling container, which was great. We got a lot of good ideas, but there was, well, how do I get it? And how do I transport it? Which became themes other years. So this year it's the operations on the surface. We're picking up the samples and the systems for storing them, gathering and storing them on the surface. Don't focus on how you get it back to Earth. That's the subject of another thing. It just has to fit through the door or hatch or be carried by some existing or planned transportation system. Don't make it too big to get back.
And number 2, are there any tips or considerations you recommend for aligning our concept with the mission needs and requirements?
So everything there is in the theme through illustration, right? But you have to address those use cases described in the architecture definition document. There has been a continuous debate between the engineers and the scientists on how we get good science and gather things and store them on the surface. The engineers want it to be efficient, the scientists want it to be plentiful. So you have to read that ADD and you'll see the nuances in the conversation there. Again, consider the extensibility to operations on Mars, because collecting samples on the moon and Mars, other than the cryogenics, might be a little bit different.
All right, next question. Does tens to hundreds of kilograms mean that the team must design for the full range, or is it acceptable to target a specific capacity, like 50 kilograms, within that range?
So teams can target a specific capability within that range, but should recognize that the value of their concept is based in part on what the capacity is. If you design a whole system that gets an ounce back, well, Orion could carry already 100 kilograms back. If it's only rocks you pick up on the surface, that's probably not valuable to the scientist. So again, go back to ADD, lead the discussion. What's valuable? What's of highest interest? And that's how you can decide how to best implement your approach.
All right, and for the samples, should teams be prepared to support all 3 states, unconditioned, refrigerated, and frozen simultaneously, or can we focus on a subset depending on mission traits? Additionally, are there specific temperature and storage duration requirements for refrigerated or frozen samples?
So yes, there are, I'll go to the second part. There are specific temperature and storage duration requirements. It's in the ADD. If you go to section appendix D.2, that stuff is in there. But as stated previously, we really want a wide range of states. It is a way of operations for doing science and sample return. And if you focus too narrowly, you'll miss out on the greater good and how all that stuff works together.
All right, moving on to the next question. For intravehicular samples, for example, human research samples, are there specific contamination control or biohazard handling requirements we should assume? For extravehicular samples, should we consider volatile-rich materials like lunar ice, or focus on geological rock or soil?
So we'll go back to see the ABD about the range of things we want you to look at. We want to look at a wider range, not focusing on one particular aspect of it. There's enough stuff out there to identify what they're looking for and then the requirements for the environment and storing them in the ABD and the appendix and elsewhere. So go do your research.
Next question. How detailed should the transport chain be beyond the lunar surface departure point? Should teams define only high-level transfer concepts, or is some integration with existing Artemis logistics systems expected?
So we're not expecting you to do delta V and orbit mechanics calculations of getting the sample back. But we want you to understand how big, as I said before, the doors and hatches are, whether they're pressurized or unpressurized. Orion itself can only bring back 100 kilograms of payload. So we haven't solved the transportation leg for tens of hundreds of kilograms of samples. But we do know we want them. And we know that we're going to have, Orion's the only ship now that comes back to the moon. So there might be some sample in the future where they take it to a orbiting space station and it's processed there and pieces are brought down. We don't know that. And we don't want you to work with that. Just want you to be aware that it has to get back to Earth somehow. And you have to factor that into it.
Thank you, Pat. Next question. The guidelines say this should not be the emphasis. So would a basic outline of transport to Earth, for example, orbit planning and mission architecture from Earth to Moon and back, be sufficient? Or do you expect subsystem level trades, for example, reentry capsule concepts?
So we're not talking about, again, as I said before, we don't want you to look at how you actually get it back to the surface of the Earth. We just want to make sure that you can find it'll fit in something that'll get off the surface of the moon. So keep it to that particular level. Again, if your concept is that you loaded up a big pallet on the Starship and the Starship doesn't have a crew, but it goes back up to space. Now you got this big pallet on the Starship. So now what is it? How does it get back to Earth? I don't know. So think about that as you do this. It might be smaller chunks are better than bigger chunks.
So what is the mission's time frame? How would that time frame impact the level of technology we can assume is already on the moon?
So I mentioned the ADD. There's a description of something they call the foundational exploration segment. We call them segments because they're not phases, because they overlap with each other. So as humans return to the moon, which is the HLR segment, they begin setting up this foundational exploration capability. So they mesh. So you want to start doing your sample return infrastructure, concept, methodology, whatever it is, in that human return segment, but it needs to be at its full potential in the foundational exploration segment. Again, read the ADD.
All right. All right, that was number 8. We'll move on to number 9. To what level of detail should cost estimates be made? Should teams provide rough order of magnitude ROM estimates or a more detailed subsystem level assessment? Also, should launch and transportation costs be included or only costs for unique systems developed by the team?
So my dear friend, I had some dear friends who did ISRU, NASA, and they would design a system. They would say, look, I have this system. It only weighs 100 kilograms, but it can produce 1,000 kilograms a year of oxygen. So I'm saving all this money transportation. But what he didn't include was the cost of the nuclear power plant to run his system and the delivery of that system. So yes, of course, everything required to launch, land, and field your systems that's unique to you has to be included in your cost. So you can do, if it's a new system that no one's ever done anything on, yeah, we want to do a detailed cost assessment. We want to do it by subsystem, build it up. But if it's something else you're using or a service that our MSO already has, to say we're going to use this, you don't have to pay the development cost for it, but you have to apply the service cost for it. So yes, we want detailed cost estimates, but only where the detail is required.
All right, the next one's a long one. This theme has been a common research topic for decades. Do you have any advice on how to stand out in this theme? How do we make sure we aren't doing unnecessary, redundant research or work?
I mentioned this had been several, and you're correct. This theme has been a common research topic because it's important. We're going to the moon and Mars for political reasons and for scientific reasons and commercial reasons. So this is the scientific reason. This is why we go. If we're not going to do science in a good way, not going to bring back good samples, we're not doing our justice. So it's always been a spirited discussion between the scientists who want to bring back tons and tons and tons of things, and the engineers just say, don't bring it back, just analyze it there, save all that mass on the surface. Bottom line is read the ADD. The ADD says what we want to do, what is important. So you say, how do we make sure we aren't doing unnecessary redundant research work? Read the ADD. It'll point the way. It's your flashlight to the architecture.
Moving on to the next question. The theme states there is a de-emphasis on cryogenic samples. Can you explain what that means? We're hoping for more of a description. And what types of samples are most important to NASA? Are they looking for biological or regolith samples, or are there specific sample types that we should focus our collection on?
So we covered this all before. Read the ADD. All these cases are in there, and the limits and stuff's there. The reason why there's a de-emphasis on cryogenic, but it's not really a de-emphasis. It just means we don't want you to solely focus on that. Because we had a topic in RASCals a couple of years back about a cryogenic sample container. So we don't want to repeat that. We want to look at the whole operations of looking for the sample, finding the sample, acquiring the sample, picking up the sample, storing the sample, and then putting it in some sort of queue to go back to it.
Number 12. Can you clarify the primary science priorities for sample collection, sample types, geological, biological, or material preservation focus? What sample types should be prioritized, and are there certain samples that would be of highest importance? For example, ice from PSRs. Are there any specific sample requirements, or do teams have the agency to determine which samples are valuable for the mission?
So it's a good question because it depends on which scientist you talk to, what the most important thing is. So in the ADD, it's all listed. They're all high priority. They're all important. So state your rationale on what you think is the most important and why for your priorities, because that's important to us. It might be that you might come up with some logic that we haven't thought about yet that says, hey, we want to collect these samples from the PSR before we go to the top of Mount or get a couple of or something. Yeah, state your rationale.
Thank you. And moving on to the next slide, the added objectives get higher consideration.
So this is, I snickered when I wrote this one. I was a little flipping it. Sometimes these added objectives can seriously weaken the concept if they take away from the NASA objectives. Choose wisely. So sometimes we've had folks that come back and say, we got this great idea, and they work this concept of an objective that NASA didn't even have. It might have been a really good objective, but they ignored what was in the themes. So go ahead, if you focus on the objectives and the themes, great, and you have a new objective that says, by the way, we can also go down into a cave and get stalagmites on the moon or something like that. That's great. That's great. But don't focus your concept on getting stalagmites out of the moon, out of the tunnel in the moon.
All right, and is in situ testing weighed heavier than post-mission analysis?
So I already said this. That depends if you're talking to an engineer or scientist. The scientists are in charge of the lunar sample return. Sample collection is all about post-mission analysis right now. The samples are about getting it back to Earth, getting the university and the research community, getting all of a piece of it so they can do their focused capabilities. There are systems on Earth that weigh hundreds of tons. You can't take that to the moon. So the priority is to get it back. So kudos to the person who said in situ testing. Yeah, I like that too, but that is not what this theme's about.
Are we allowed to use pre-existing technologies in our design? For example, instruments getting to the moon for rockets and landers and getting back to Earth.
Most certainly. Innovation is not about new stuff. It's about how you use stuff, whether it's new or old.
Next slide. How many lunar days or months is considered long-term storage for these samples?
So I mentioned that we can't get a lot back at a time. And here I'm mentioning that initially crews only go to the moon once a year, maybe every other year, depending on the architecture. There may be a backlog to transfer samples back to Earth, so plan accordingly.
How extensive should the scalability plan be for Mars integration and other planets?
Hey, it's not scalability we're talking about here. We're talking about extensibility. So the extensibility of the operations and systems of Mars is important. Scalability applies both to the moon and Mars, but is not a driver for this thing.
Thank you, Pat. PSRs, permanently shaded regions, could contain valuable insights about the early solar system. How much are we expected to limit our disturbance of these crater regions?
PSRs permanently shadowed regions. Again, see the ADD. We have a basic disconnect here between the ISU community and the science community. The ISU guys want to strip mine it, and the scientists want to preserve it for all eons. why don't you, we want to hear you guys' perspective on how we address this disconnect.
NASA has developed the Trident drilling system and wheels for the Artemis architecture. What components are we able to reuse conceptually in our design?
So a plug for Rasmus here, the first award we gave was for a percussion drill on Mars, which is where the Trident is. So what you're seeing here is original Rascal concepts come back around again in the question when it's going to the moon. So anything developed for Artemis is fair game. You have to cover the development costs, but you don't have to include the cost for additional hardware sets. And you will have to include it for additional hardware sets in deployment and service. But the development cost is not required because someone else has already covered it.
That was RASC AL 2002.
Very good.
Are we able to assume the use of clips?
Yes. See theme 4. And in fact, I'm gonna embellish on that. In talking to the theme developers, they said the reason why we chose clips is we don't want to see a bunch of unaffordable things landed on a starship. So they want a stepwise piece, and this 1,000-kilogram limit, the small clips-like delivery system is the size they want to see for these payloads.
Is there a technology you want us to use or avoid our focus on?
No, unless it's magic.
So should the concept prioritize technology demonstration or science return value?
So in this particular one, it's science return value.
All right. And is there a required orbital architecture like NRHO, LLO, or direct ascent?
No, because again, we've asked you to focus on the surface and not concern yourselves too much with how it gets back there.
Should teams assume integration with existing Artemis systems like Gateway or HLS?
If it yields better performance at reduced cost, there's no requirement to use the Gateway or HLS.
What are the expected delivery and deployment constraints for the surface system?
See the cargo lander section of the ADD. It talks about payload sizes and volumes and stuff like that.
To add on to that, we did get a question in the chat about where to find the ADD. You can take a peek at the RASCAL resources page, and you should be able to find a link to it on NTRS there.
That's how I found it.
It's also in, if you click on the recommended reading, it's about the 6th or 7th bullet down.
Thank you, Stacy. Number 37, where is the geographic location on the lunar surface that is specified for sample collection? Are there specific lunar landing site regions of interest or latitude constraints? And how many samples are you looking to collect in different regions in volume and or kilograms?
So the initial place where people are going is going to be the lunar South Pole. That's our targeted state as of now. The science community has a great desire to obtain samples from all over the moon. So later on, towards the end of that foundational exploration segment, or maybe beyond that, you could see a system that combines global and local access. The sample return is not just necessarily rocks that humans pick up. It's robotics doing quarterings. That's going on Mars right now. So see the ADD for more details.
All right. That was 37. Moving on to 38. Is Earth re-entry and recovery part of the team's responsibility, or can it be notional?
As I stated before, it's going to be notional. Just make sure there's some idea, some reasonable expectations that it could be got back to Earth in some way.
Are we allowed to implement artificial intelligence into our design, not as a tool to help us make the design, but as a part of the design itself?
The answer is, of course, yes, if you just information analysis. No handwaving says, well, AI is going to determine how the best, what sample to pick at this spot, unless you tell us how it's going to do that. I mean, AI right now runs on giant servers on Earth that go through the World Wide Web pulling up information. We have to implement it all on the moon, so no hand waving.
41, are we restricted on the total budget of the design, or is it just something we have to be aware of?
This is a common theme here. They didn't give budgets this year. Last couple of years, I always gave budgets to keep people in the box. But I'll just caution you, if it's really expensive on the approach of the cost of an actual crewed mission, you'll raise flags. Be reasonable. We're expecting you to tell us what it is.
42, 2, is there a certain TRL which a certain technology must meet in order to implement it in design?
So again, this is sort of a tricky question because you can implement lots of low TRL technologies in your design, but they have to demonstrate how they're going to be operational, actually. So how it goes from a low level to design to 9 operational.
Are sensors required to transmit real-time data to Earth, or can data be scored locally?
That's part of your implementation, justify your decision. Both aspects probably make a good, robust system.
Are we allowed multiple rovers for different operations? Could one be used for drilling and packaging samples and another be used for sample transport to relevant sites?
Yes, next.
Can we use one storage system for all types of lunar samples, or should they be separated?
Again, that's up to you because every set of operations and concept of operations will have unique system requirements and things. So justify design via analysis based upon your operations and systems.
Which orbital devices or satellites can we use in tandem with our robot to identify potential dig sites?
That's totally up to you, but that includes cost of leveraging those systems in your operational costs. You just can't say someone else is going to deploy a system and we're going to use it. So if it's there or it's already in the plans to be there, then yes, you can leverage it. But how much are you going to leverage it? How much data are you going to take? How long is it going to take? All that type of stuff.
51. Should the sensors for sample identification be specified to look for certain elements, or should it provide broad general data that we transfer back to Earth and interpret?
This is why we're at this theme, to get good ideas on answering these very nice questions. Up to you.
Next question. Can you have things near the landing site to collect and use when needed? For example, have a larger excavation tools near the landing site and a smaller set of tools to test the new surface. After testing, the module could be swapped out for the special tools.
No restrictions to such an approach, but again, just don't say, well, someone else is going to provide an excavator and I'm going to use it.
Should tools be designed to avoid cross-contamination when switching between multiple samples, or is cleaning between uses expected?
And read the ADB, choose a strategy, and justify the benefits. We're not going to tell you how to do this. We want you to tell us how to do it.
Last question in the lunar sample return concept theme. Should surface operations assume crew interaction, or must all collections be robotic? Must this mission be unmanned, or should we plan for astronauts to acquire samples, or should we rely on robots?
So we sort of discuss this before. Robots and humans can work together. Humans are there. And robots can do things more slowly than humans have done. Robots can do things that are more dangerous than humans. This is what we're looking for, you guys. We want to understand what your strategy is for optimizing the sample collection in these ships between robots and humans.
All right, we'll be moving on to the fourth theme here, lunar technology demonstrations, leveraging common infrastructure. I have seen a couple of additional and follow-up questions here in the chat. Please feel free to continue listing your questions there. We're going to start at the top when we get to the additional questions section, and then we'll read them off, and if Pat's able to answer them, he will do so. So go ahead and pop your questions in there at any point in time between now and then. The first question is a doozy. The theme states proposals need multiple CLPS class payloads delivered using a single common mass and volume. Does this mean one CLPS landing carrying all payloads, or 2 multiple CLPS landings, each with the same payload capacity? Is there a 1,000-pound mass limit intended per individual technology demonstration concept, or is the total combined mass for all concepts within the proposed campaign, or per launch vehicle? For example, if utilizing a large lander with multi-ton capacity, would it be permissible to send multiple payloads within a single mission? If it's per payload, is there a limit on the number of such 1,000-kilogram payloads that can be delivered over time?
So I thought this was an excellent question because I had the very same one I read. It wasn't clear by reading the themes what they actually meant. So I'm going to start off by telling you, I already said this, but what they didn't want. They didn't want a bunch of giant starship-sized payloads, because it's not affordable, it's not doable. But sometimes when we say demonstrate industrial scale ISRU, well, then they have a power plant, then a bulldozer, they claim, no, This is a stepping stone. So what STMD wanted was stepping stone, affordable, that get us to those objectives, L1 through L8, I think it was. So and with much, there was some interaction here where I got clarification from the theme owners, and it turns out I read it right because read this stuff too much. All right, so I'm going to read what I wrote here because it's a long thing. All right, so the CLPS landers associate this theme medium class size, hence the 1,000 kilogram lander limit. So any chunk that comes to the surface is not going to be any bigger than 1,000 kilograms. Why? Because it puts you in a certain cost box for initially because of the sidewall payment. A campaign or one or more lander missions, when combined, addresses the theme. So is it one lander? Is it two landers? Is it 50 landers? You can have 6,000 landers if you want. Each lander can't be more than 1,000 kilograms, but guess what? You're not going to get 6,000 landers. Think more on the order of 1, 2, 3, 4 or something like that. Because there's only a certain amount of CLPS landers. CLPS would also like to normalize the payload volume and maximum payload mass across these. That's why they want to have this standard. They want you to come up with a standard volume for a 1,000 kilogram payload mass that addresses those lunar objectives, lunar infrastructure objectives. So your common volume would probably be driven by the largest payload in your campaign. And the other ones would just have extra space in them. They would like each mission to be feature packed. So you want to get to close to your 1,000 kilogram. Right? Sometimes it doesn't do that. Sometimes you can make your limit. If you want to add like 500 kilograms of water because you don't have enough, well, you could bring that too if it's part of the technology. Remember the items like ramps for offloading rotors must be included in the payload mass. So anything that's unique to you that's on top of that lander, that comes out of your 1,000 kilograms. Again, I said you can have a bunch, but it should be reasonable given the CLPS launch rate and cost, and that's historic. So we've had a few CLPS landers go down to the surface. We've had 1 or 2 landers actually land right side up. But this is that type of class thing. It's small, it's focused, and addresses the combination of those lunar infrastructure objectives.
Thank you, Pat. Hopefully that provides some additional clarification on the theme. And we'll move on to question number 2. Concerning the integration to CLPS class payloads and how much teams are to discuss each concept will integrate with the CLPS class payload and the concept deployment operations to the surface, considering that CLPS landers vary in configuration.
So again, you're sort of establishing this 1,000 kilogram TBD volume, and that volume has to be compatible with CLPS class launch vehicles too. So you have to do a little orbital mechanics that says a rocket this big and a CLPS lander can land 1,000 kilograms at this particular point. But you're specifying what those volume limits are and what you're targeting. So we would expect to see for each one of these, you would have a picture of what it looked like on the CLPS lander package and then how it got off of the CLPS lander.
When developing our concepts, should we design technologies that are inherently capable of operating on both the Moon and Mars, accounting for environmental differences, or should we focus primarily on lunar operation while identifying how the design could apply to Mars?
Yeah, I mean, it leans a little bit toward the latter part of it. Either approach is fine, but so STMD, these are their lunar babies here. They have a similar set of objectives for Mars. But focus on the Moon, and if you got extensibility characteristics, document brownie point.
Should our cost estimates include only the team's unique technology development or also integration and delivery costs under CLPS assumptions?
Yeah, delivery and integration costs under CLPS assumptions should be, because again, it's the cost to NASA of fielding these things. So you always have to include transportation.
What qualifies as incremental demonstrations? Should each payload build upon the results of the previous one, or can they operate independently while leveraging shared infrastructure?
Both approaches are acceptable.
For common infrastructure, should teams define how these services are used, for example, power, data, logistics, or also propose how they are implemented?
So if the infrastructure is being provided by your concept, you need to show how it is implemented. If you're leveraging RMS infrastructure, let's say there's the, fission surface power plant. You could say, well, there's a part, Artemis and Foundation Exploration has this fission surface power plant, and we're going to use the power plant. But how much power am I going to use? How frequently am I going to need that power? Those type of things you need to convey.
Should teams identify providers of services, for example, CLPS landers, power grids, or only define how their concept would interface with those services? And what is the level of detail required for describing infrastructure?
So that's question 7. Then we describe what kind, level, and frequency of services required from Artemis infrastructure, including EVA and IVA crew time. So a lot of people don't think about that, but as I mentioned before, EVA crew time is extremely costly. So don't rely on it too much.
How many CLPS payloads are we allowed? For example, how much can we rely on Earth-made materials?
So it's as many CLPS flights as the production line and budget can support. But be reasonable. $1 billion tech demos are few and far between.
What's the expected fidelity of the cost estimate, rough order of magnitude, or detailed subsystem breakdowns?
So we've been over this a couple of times, but if you use NASA endorsed cost models, they're usually written by subsystem level thing. But analogs and published prices can also be used. So you've got data that says each CLPS mission costs $200 million to land. Reference it, use it. Don't cost you.
Number 11. Should the design include any hardware that makes up the CLPS landing system or that interfaces with the CLPS lander?
So yes, anything unique to your mission that is on the CLPS lander must be costed. So it must include the cost of the launch vehicle and the acquisition of the lander, but not the development. Same thing going on.
Should the design include orbit design for the trajectory between the Earth and the Moon?
No, this could be a service. So you're going to get 1,000 kilograms landed there. But again, you have to show how that 1,000 kilograms would fit on that particular number and be deployed from that.
How broadly can autonomous manufacturing be interpreted in the LI4? For example, if a demonstration includes splitting water ice into hydrogen and oxygen, would that be considered ISRU under LI7 and autonomous manufacturing under LI4?
I think any good lawyer would say yes. Indeed, overlapping. You can take credit for multiple objectives with one overlapping type thing. So yes, but prepared to defend your interpretation. Just if all the landers land, and as L4, L5 says, precision landing. Well, if truly your demonstration capability requires precision landing, then take credit for it. But if it doesn't, don't take credit for it.
Would storage of in situ produced resources satisfy LI8? For example, if a demonstration includes splitting lunar ice into hydrogen and oxygen, this is the same question.
It is. So perhaps, yes.
Next question, how many separate technology demonstrations are expected for successful proposals? Is it preferable to plan for 2 to 3 demonstrations in greater detail or a large number of demonstrations in less detail?
So we've had RASCAL's things where people put everything under the roof under there. And all this magic happens, somehow they all fit and all work together because they thought they get more credit for that. But actually took away from the proposal. So I advise you the optimal being is a few interrelated demonstrations in detail, but identify other observations that could be incorporated that don't require extensive detail to justify. For example, the one I used about precision landing, or your emphasis might be ISU propellant, but you need to plug into a power grid, then in a precise point, you can see you can putting them together, but justify them. Don't just handle it on.
Next slide. Theme 4 states that NASA is looking for novel concepts that provide these demos. What is considered novel? Should successful proposals prioritize demonstrating entirely new technologies or well-researched technologies that have yet to be tested?
I think I said this before too. Novel does not always equal new technology. Novel is just a different and hopefully better or innovative way of doing things. Combination of design, operations, and technology is a better way to do this.
Is there a generally accepted or recommended timeline over which these tech demonstrations should take place? Should our campaign timeline start at T0 at Earth launch or lunar landing? And we'll include payload development and surface demo timelines, but do we also need to account for the post-development pre-landing period given CLPS launch/provider uncertainties?
So for the 90% of it should be 1 second after landing on the moon. There might be some things you're doing, during the transfer to prepare the mission. There might be a camera on there that you might want to activate before landing. But most of this is about demonstrating the lunar demonstrations, which are basically surface-based, except for I think there's a communication one. So it's a service you're buying. You're not designing the CLPS lander. So most of it's after it lands, but if there's some things that happen serendipitously because it's coming down and you're over a certain site and it helps you bring, then yes, bring that in. So I'm modifying that a little bit.
Is the theme focused on surface-based technology, or could it also include orbital systems and transport systems like cargo delivery and distribution systems?
Yeah, so it's focused on getting these things down on CLPS landers. So it's really based on the surface technology, surface-based operations. The infrastructure objectives certainly include orbital aspects, but your concept should focus on the CLPS payload. However, if your campaign payloads have to rely on orbital infrastructure to accommodate objectives, state the need for the orbital infrastructure will be, and either drop it off as a hitchhiker or if it's an Artemis system like the Gateway or something like that, say how you're going to use it, justify it.
Of our technological demonstration driving the proposed campaign, does each demonstration need to be its own system with its own design requirements? For example, does the number of demonstrations determine the number of systems we design? And how does this relate to the payload number?
So each landed mission in the campaign needs to convey what the payload is, its size, mass, packaging, what its operations are, unloading and activation, and the objectives, and the metrics associated with how it addresses those mission demonstration objectives. And the theme's very specific. It wants to make sure that you describe how it interacts and impacts, enhances the existing lunar infrastructure. So it's a story. There's a book called Lunar Technology Demonstrations, but each chapter is a mission, and the book's called a campaign. So it's what happens before, during, and after each one of those and how they interrelate. So it is an integrated study because in between landed missions, that payload is doing something, maybe preparing for the next one. So yes, we will know that.
Thank you, Pat. We have about 12 more technical questions, and then we'll move on to the programmatic and miscellaneous questions. What should our focus be on? Enabling scientific endeavors, maximizing profit, or setting up for future missions?
So you decide, but your focus should be on the objectives. So read those 8 objectives or where they are. That's your focus.
Can we assume any resource, for example, chemical additives for regolith refining, are already transported to the moon and do not need to be considered in the limited payload capacity?
No, that's hand waving. No, if you need it and no one else does, that's part of your thing. So anything that's not native to the moon that's required by your demonstration must be part of your campaign payload mass.
Do you want us to specifically focus on mining in the South Pole, or are there other preferred regions?
There's no requirement to focus on the South Pole, but again, that's where most of the infrastructure will be.
Can we assume there will be resupply missions in the future? And if so, how often would they be, and will they be crewed?
So you can assume a crewed mission each year, but any resupply missions that are part of your campaign are in your budget. Stuff coming down with the crew is all dedicated to other users, so you're on your own.
Would you prefer for us to operate under one system/rover, or are you open to a multi-rover system?
We are open to more than one rover and things that move that are beyond rovers. Think innovative.
How long will we have to develop a strong lunar infrastructure before it is to be extended into industrial scale operations?
So we talked about this before. We don't have dates on our timelines. It depends on discovery, advancements of the transportation system, and politics. Politics don't impact anything, do they? Oh, wait, no NASA guys here today. So no one knows, but we want to be ready as soon as possible. So you have to be smart in how you time things and justify them.
How should transportation be demonstrated if mobility and logistics are already defined and, as assumed, common services? And what aspects of transportation infrastructure is NASA most focused on developing?
There are things like hoppers, rail lines, and gondolas examples that are transportation gondolas discussed in the ADV. Innovate.
Considering the proximity of this theme to current lunar technology demonstration missions, is the intent to refine or redefine how existing missions are conducted or to propose entirely new demonstration missions not currently planned?
Yeah, focus on the new missions, please. RASCALs is not about redesigning current missions.
Level of detail should the scaling roadmap extend in order to demonstrate early industrial capabilities with potential for growth toward full-scale industrial operations?
So I'm lagging. Didn't change on my screen. So there we go. Now it did. You're too fast, Tori. Okay. Read it again as I read it with you.
To what level of detail should the scaling roadmap extend in order to demonstrate early industrial capabilities with potential for growth toward full-scale industrial operations?
All right. So there's two ways of scaling. There's replication or scaling, delivering bigger systems. Just show how that works and how they can reach industrial scale. So if I've got my demonstration unit produces 10,000 kilograms of bricks a year, and I put 10 of them together, now I've got 10,000. Stuff like that. But you don't have to design a bigger system to show industry. Just show how it would go or how the technology produces it.
If our technology demonstration involves building or testing a common infrastructure component, such as the TLT, should the mass of that infrastructure be included within our overall payload mass constraint?
So if you're bringing the raw materials from Earth, yes, it has to be in there. You can't assume someone else is bringing it. If it's built out of lunar material, you must include the mass of the delivery of the systems that convert the regolith into building materials, as well as systems to move the materials. No free lunch.
No free lunch. Next slide. To what extent may teams modify existing common infrastructure elements? For example, are modifications to a payload delivery vehicle, such as a lander, permitted? And if so, what are the allowable boundaries for those modifications?
I love this question because this is how I challenge things too. Tori's looking at her watch, so I better talk with her. In this particular instance, I'll give you an example. If I had a hopper, my demonstration was a hopper, refillable hopper. I wouldn't put a hopper on top of a lander. I would modify the lander to hop. Can't do that in this thing because it's all the 1,000 kilograms above the lander deck. So keep it that way. I know it limits innovation a little bit, but it keeps everything even keel across the proposals.
Good to know. And this is the last question in this theme. To what extent are teams expected to define the architecture of the common lunar infrastructure? Which assumptions can be made versus it must be explicitly defined, particularly regarding shared services such as power and communications, manufacturing, and construction demonstrations? And is NASA primarily seeking validation of the processes themselves, or is the emphasis on how those processes can be integrated into the broader common lunar infrastructure?
So there's lots of discussion on this in the ADV. Read the content for the foundational exploration segment and the sustained lunar exploration segment. I wrote the sustained lunar exploration segment, so I know that discussion was in there. There are descriptions of infrastructure expectations in those segments to state which segment of chain you'll have to operate in given the infrastructure needs of your campaign. So you don't have to say 2035, but you could say early in the SLE segment. And that'll put you in a common context for what's going on and what the infrastructure looks like.
Thank you, Pat. And that is the last of our technical questions here. We want to thank Pat. He will be answering, however, your questions. They get submitted into the chat if we have any additional time at the end of the Q&A session. So go ahead and pop them in there. That way we can read them off when we do have additional time. We will now be moving on to the miscellaneous and programmatic questions that were received in advance. Additionally, I do want to mention if your question was not responded to here on the call, it is in our queue. We did receive it. However, these are a selection of questions that we wanted to answer for y'all so that you can continue working with additional context on these themes. You'll be able to see the answers to all questions received in advance after the shutdown when we have all of those documents posted online. So here in the miscellaneous and programmatic questions, we'll have Jen Eberly read the questions and I will provide the responses. Jen?
First question, what are the most common oversights, weaknesses NASA has seen from students' RASCAL submissions in the past? What common weaknesses or pitfalls have evaluators noted in previous competitions?
That's a good question. Review the tips from the review panel on page 14 of the RASCAL competition guidelines. This list encompasses common issues and weaknesses and the judge's advice on how to be successful. This list is actually reviewed and updated every single year with lessons learned from the previous year's competition, so it is kept up to date, and we do really encourage you to read through it carefully and apply what you see there to your proposal.
Next question, if we have a physical prototype attached to our submission, how can we show that it works for additional credit in the competition? Will we have to repeat this at KSC too?
Good question. Just to clarify, the RASCAL Forum is not directly at Kennedy Space Center. It is at a hotel in Cocoa Beach. So phase 1 submissions include only a written proposal and video. There are no bonus points or expectations for a prototype at this stage. However, if your team chooses to develop one, the video is an excellent place to showcase it in action. To earn additional prototype bonus points in phase 2, teams must demonstrate their prototype in person at the RASCAL Forum during their presentation and during the poster session. So how you choose to demonstrate it is up to you. Previous teams have done so by bringing their prototype physically to the forum. They may include VR simulations, they might show video demonstrations, or showing a 3D printed model of their systems. So what you choose is really going to depend on what's feasible for you to bring and present at the forum. It should not limit, however, your prototype testing at your university.
Next question, how are stipends intended to be spent? Is it mainly for travel or prototyping or otherwise? And what do you do with the rest of the money when the competition is over?
So I'm going to read this one directly. Neither NASA nor NIA can direct how stipends are used. Stipends are meant to facilitate finalist teams' full participation in phase 2 of the RASCAL competition, which could look a little different for each team. Previous teams have typically used the funding to support the development of their technical paper, poster, prototype, and/or covering travel costs to attend the RASCAL Forum in Cocoa Beach, where the final presentations are delivered. The team's advisor is ultimately responsible for determining how stipends are allocated, including any remaining funds after the competition concludes. I want to clarify here that the team's advisor refers to the primary proposing university's advisor. If you are a multi-university team, you are going to be looking to that primary university advisor.
Next question, in my confirmation email for the NOI, it said there is a Q&A session on Thursday, November 20th, 2025 from 3:30 to 5 p.m. Eastern. Will there be another QA or was this a typo?
That was an error. This is the only 2026 RASCAL Q&A session, and it is scheduled for today. You are here now, so thank you for joining us.
Has 12 minutes left.
12 minutes left.
Next question, are there preferred formats, software, or templates for schematics, models, videos, and other deliverables?
There are basic formatting guidelines for every deliverable that must be followed. For those guidelines and any other questions on rules and requirements, please carefully review the 2026 RASCAL competition guidelines. We've laid everything out there extremely clearly, so if you have any questions about the specific requirements, we can go to the next slide for additional questions. But
are we allowed to ask more questions to clarify something in the future? If we have additional questions or need clarification down the line, would it be possible to reach out via email? Or are there any interim meetings scheduled for feedback or check-ins during the competition timeline?
There are no additional Q&A sessions planned. However, if you do have questions at any point in time, please email them to rascal@nianet.org. Submitted questions will be posted to the RASCAL FAQs webpage rather than the Q&A summary document from this session that will be posted after. So check that FAQs page regularly for any updates. That's where they'll be posted. Along those lines, if you do have additional questions, we can go to the next slide, Jen. Thank you. I do want to take a moment to introduce you to the RASCAL program team. Each question will be responded to directly, as well as posted on the FAQs page for everyone to review. It says that the questions from the call will be transcribed and posted on the RASCAL FAQs webpage about 1 week from today. Just understand, and we hope that you can be a little flexible with us as we are moving through the government shutdown and the furlough. This will be posted as soon as we are able and allowed to. Along those lines, of course, we do have Shelley Spears here joining us today. You've already heard from Stacey Eves. I am Victoria O'Leary, and Jen Eberly has, of course, helped us here with the programmatic questions. Now, I want to invite everyone to pop your question into the chat if you have one. So we will go ahead and covering those questions in the chat as they have been received. So going all the way back, Pat, we have one follow-up question, which I think is for theme number 1. For the sample return, should or could we focus on the sample identification system and sample collection system, for example, rovers, navigation system, etc., or should the focus be around the sample itself once identified and or collected already? And just as an FYI, you don't have to answer every question if you prefer to wait for.
No, so the theme really wants to encompass that part of identifying the sample and collecting it. So it's cradle to grave, essentially, from the ground to the box. So it's not just someone else has previously identified as the sample, let's go get it. No, it's that entire process.
Jen, do you mind popping back to slide 3? And we have another question. I think this one is related to lunar surface power and PMAT architectures. So you said the surface is more important to you than the subsurface samples?
No. Okay, so what I meant is the surface operation on the lunar surface, not subsurface counts as lunar surface. It's not the leg of the operations that happens in getting it back to Earth. So lunar surface, lunar subsurface, cryo, drilling. That's all equally important. You establish what the priority should be. Sorry if I misspoke.
Thank you for the clarification. All right, we'll move on to our next question. For the sample return, I did ask that one. For theme 3, is it safe to assume multiple missions for multiple sample returns, or are teams restricted to only singular mission to return samples just once?
So it's really about gathering the samples on the surface and having a cache of samples there to be returned at some later time. So it really isn't 1 or 2 separate return missions. It is how you acquire, manage, and store samples on the lunar surface.
All right, we're going to move on to this programmatic question. Can we add more people to teams that are already listed in the NOI? In other words, if the NOI has been filled out and more participants want to join my team to work on a theme, is it possible for the new people to become part of the team? And do we have to fill out a new NOI with the new participants who join? Are there any limits on numbers or anything else to consider? This relates to creating international/multi-university teams, USA and Colombia. Good question. You can find the answer to this partially located in the competition guidelines and partially located on our FAQs page. There is no limit to the number of students that can participate on any specific RASCAL team. However, you will be limited to 10 participants at the forum itself unless you request to bring additional people. We will only approve requests up to 15 people per team at the forum just because of we have some space constraints. And you did also ask if a new NOI would need to be submitted for that. No, go ahead and include that full list on your proposal. And then if there are any changes between when your proposal is submitted and if you're selected as a finalist, your final technical paper, go ahead and include any changes to your participant list on your final technical paper from the proposal stage. So whatever the next deliverable is that you qualify for, you would include updates there.
So the answer is simply yes, you absolutely can add more team members at any time throughout the year.
Thank you, Stacy. For theme 1, Pat, Should we include how human crews would get to or stay on Mars, or simply how our design would be used/integrated by crews once on Mars?
Yeah, once on Mars, don't worry about how they get there.
Should we include orbital mechanics of our launch or just the manifest you mentioned earlier?
So if it's an existing launch vehicle, which you probably want to go with, you just have to state it's within that vehicle's performance capability to get this satellite to this orbit.
Should we base our timeline off the current NASA planned Mars missions, specifically in regards to humans on Mars?
I would like to know what that official date is, because we never set one.
There you go.
We've always weasel worded that one. It's going to be well into the 2030s.
Okay. All right, another question from Amber. For our project proposal, should we include the potential materials and technologies we plan to use? For instance, the nanotechnology or nanomedicine components, or should we focus mainly on the design concept and functionality?
Potential materials is very important in establishing feasibility. If you say my payload's made out of balsa wood, we're going to question it. If it's made out of carbon nanofibers and we know only one thimble of those things have been produced, we're going to question that too. So if it's just basic aluminum and stuff like that, that's fine. But if it's something exotic, you probably want to identify it and justify it.
Also from Amber, should our design address how human crews will travel to and remain on Mars, or should we focus solely on how our concept will be utilized or integrated by crews once they're already on the Martian surface?
The second part, I'm asking for any transportation systems for humans to Mars.
Right. And this is an additional question for our project proposal. Should we include... Oh, this was already answered. Thank you. All right, so if you've got any other questions, go ahead and pop into the chat and post them there. They might not be answered verbally on this call, however, we will record them and include their responses in the Q&A session summary document that does eventually get posted when we are allowed and able to do so. I do want to move on down. Jen, if you could take us to slide 69 to the upcoming important dates for the 2026 RASCAL competition. So we do want to clarify a couple of dates here for you. Phase 1 is for proposers, and the next upcoming date that is most important for you is February 23rd, 2026. That is the deadline to submit proposals and videos. We do not accept late submissions, so make sure that you are submitting those by midnight Eastern time. Now, if you would like to submit additional NOIs, we have extended the NOI submission deadline all the way up until midnight on February 23rd. So if you are forming an additional team or one of your friends wants to submit a concept and they're eligible and at a university, please feel free to do so all the way up until February 23rd when their proposal is due. We will send notification of selection status on March 20th, 2026. So that is the date when we will select the finalist teams, and you will be notified if you have been selected as a finalist team. We received many excellent concepts, but we can only take 14 teams with us into the finals. So that is the date to look forward to. Now, for those finalist teams, they will move on to phase 2. And these deadlines are April 29th, which is the deadline for forum registration. May 14th will be the deadline for those teams to submit their technical paper, which is the first of the final deliverables that are due. Then on May 28th, you will be responsible for submitting your forum presentation and your poster file for the forum. I want to clarify that we do not print posters for teams. You do still need to either have it printed and bring it on site or bring it with you. And we will be playing the presentations from the file that gets submitted. You will not be connecting your laptop to the system. Instead, we'll play whatever file you submit there. Then the RASCAL forum dates have actually been updated. So take a look here. The new dates are June 2nd through 4th. They've just been shifted back one single day. And that will be in Cocoa Beach, Florida. And our winners will, the first and second place RASCAL teams will receive an additional prize. And they will also present at a mid-year aerospace conference to be determined. So keep an eye out for that at a later date. And we are right at 4:30, so go ahead and keep posting those questions into your chat. However, we do want to thank everyone who has been able to help us today with the call, especially Pat. Thank you so much. I want to say thank you to our team here at NIA. It's going to be Shelly Spears, Stacy Dees, and Genevieve Eberly. If you have any questions in the future, please feel free to reach out to rascal@nianet.org. That is where you will submit all future questions for response, technical, programmatic, any kind of questions that you have. Submit them to that email address and we'll try to get an answer for you. Other than that, thank you all so much for being here and submitting questions in advance and attending. We really appreciate your time and we're so grateful to have been able to answer these questions for you. And best of luck to all of you moving into next year and the proposal. Thank you, everyone. And this is officially the end of our Q&A session.